Tell me about a time you dealt with competing priorities. Introduction. This is a common behavioral interview question for software developers, backend developers, full-stack developers, senior developers, and team leads. Interviewers ask this question to understand whether you can prioritize work effectively, whether you can handle multiple urgent tasks, how you communicate trade-offs, whether you understand business impact, how you avoid rushing low-quality work, whether you can manage stakeholder expectations, how you protect important delivery goals. This question is especially important for check Java developers, backend developers, Spring Boot developers, full-stack developers, senior software developers, team leads, Agile teams, production support teams. The best way to answer this question is by using the STAR method. STAR means S. Situation. Explain the background. T. Task. Explain your responsibility. A. Action. Explain what you personally did. R. Result. Explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to understand how you evaluated priorities, communicated clearly, made trade-offs, and still delivered the most important outcomes. Question. Tell me about a time you dealt with competing priorities. Example 1. Sprint feature work and production support issue situation. In one sprint, I was working on a new Spring Boot API feature that was important for the sprint goal. At the same time, support reported a production issue where some users were getting errors while updating their profile. Both items were important. The feature had a committed delivery date, but the production issue had immediate user impact. Task. I needed to balance the sprint delivery work with the urgent production support issue. Action. I first assessed the priority based on impact and urgency. I considered number of affected users, severity of the production issue, whether there was a workaround, deadline for the sprint feature, QA testing timeline, dependency on other team members, production risk, business impact. I concluded that the production issue needed immediate attention because users were blocked. I informed my team lead and product owner that I would pause feature work temporarily to investigate the production issue. I also gave them a clear impact update. What I was pausing, why the production issue was higher priority, how long the investigation might affect the sprint story, what feature work could continue later, what support information I needed. Then, I investigated the production issue. I reviewed logs, request payloads, correlation IDs, recent deployments, and the affected endpoint. I reproduced the issue in a lower environment and found that one optional field was not handled properly. I made a focused fix. Key: null safe handling, graduation update, regression test, QA validation, production monitoring after release. After the fix was completed, I returned to the sprint feature and adjusted my plan. I focused first on the critical parts of the feature and moved minor cleanup to a follow-up task. Result. The production issue was resolved quickly. Users could complete the profile update flow. The sprint feature was still delivered because I communicated the priority shift early and adjusted the remaining work carefully. Why this answer works? This answer is strong because it shows production ownership, prioritization under pressure, stakeholder communication, risk-based decision-making, ability to switch context, delivery discipline. Example 2. Multiple stakeholder requests in the same sprint situation. In one sprint, I had 3 competing priorities. The product owner wanted a new customer search API completed. QA needed support with test data for another feature. A front-end developer needed clarification on an API response format for integration. All 3 requests were important and time-sensitive. Task. I needed to organize the work so I could support the team without delaying the highest value sprint goal. Action. I first listed all active requests and clarified the expected outcome for each one. The priorities were: complete customer search API, help QA with test data, clarify front-end API response format, avoid blocking integration, protect sprint commitment. Then I assessed urgency and dependency. The front-end clarification was quick, but blocked another developer. QA test data was also blocking testing. The customer search API was larger, but did not need to be finished immediately that same hour. So, I handled the quick blockers first. I spent a short time with the front-end developer and confirmed. Required fields, response format, sample JSON, empty result behavior, validation error response. Then I helped QA by providing test user, sample request, expected response, negative scenario, role-based test case. After unblocking them, I returned to the customer search API. I also informed the product owner that I had handled 2 team blockers first because they were stopping parallel work. Result: front-end integration continued. QA testing resumed. The customer search API was completed without major delay. The team moved faster overall because I prioritized blockers that allowed others to continue working. Why this answer works? This answer is good because it shows: correct dependency-based prioritization, correct team-first mindset, communication, correct practical time management, correct support for QA and front-end, correct sprint delivery focus. Example 3. Feature deadline and technical debt cleanup situation. In one project, I was working on a backend feature inside a large service class. The class had validation logic, mapping, repository calls, and external API calls mixed together. I wanted to refactor the class while delivering the feature, but the team also had a tight sprint deadline. Task: I needed to balance feature delivery with code quality improvement. Action: I reviewed the work and separated what was necessary from what was nice to have. The required work included: C. Implement new business logic. C. Add validation. C. Update DTOs. C. Add unit tests. C. Support QA testing. C. Complete the story acceptance criteria. The technical debt cleanup included: check, moving mapping logic, extracting validators, simplifying old methods, removing duplicated code, improving old test coverage. I agreed that the technical debt was important, but doing a large refactor during the same sprint would increase risk. So I prioritized the feature and did a smaller refactor only in the area I touched. I changed: check, the new validation logic. Check, the new mapper logic. Check, focused unit tests. Check, small duplicate code removal directly related to the story. Then I created follow-up technical debt tasks for the broader cleanup. I explained this plan during stand-up and code review. Result: the feature was delivered on time. The code improved in the area we touched. The team avoided the risk of a large pull request, and the remaining refactoring work was tracked properly. Why this answer works? This answer is strong because it shows balancing delivery and quality, technical debt judgment, incremental refactoring, scope control, risk management, mature prioritization. Example 4. Product scope change and sprint commitment situation. In one sprint, the product owner asked to add extra functionality to a report feature after development had already started. The new request was valuable, but the sprint already had committed work. The new request affected backend logic, front-end UI, QA test data, and regression testing. Task: I needed to help the team decide whether to include the new request immediately or plan it for later. Action: I first listened to the product owner's reason for the request. Then I reviewed the impact. The new functionality affected calculation logic, database query, date filtering, time zone behavior, API response, front-end display, QA test data, regression testing. I explained that adding everything immediately could put the original sprint commitment at risk. Instead of rejecting the request completely, I suggested prioritizing the highest value part. The options were: include everything now and accept delivery risk. Move the full request to the next sprint. Include the smallest high-value part now and plan the rest later. I recommended the third option. We updated the acceptance criteria and created a follow-up story for the remaining work. Result: The team delivered the original feature and included the highest value part of the new request. The product owner felt heard. The sprint goal was protected, and the remaining work was planned properly. Why this answer works? This answer is good because it shows stakeholder management, scope prioritization, business empathy, agile planning, trade-off communication, protecting delivery quality. Example 5. Production support, code review, and development work situation. During one busy week, I had multiple responsibilities at the same time. I was developing a new API, reviewing a teammate's pull request, and supporting a production investigation. The production issue was not fully blocking users, but it affected a small number of transactions. The pull request review was needed because my teammate was waiting to continue their work. Task. I needed to manage my time and make sure the most important work moved forward. Action. I first categorized the work. The production investigation was highest risk because it affected real users. The pull request review was a team blocker. The new API work was important but had more flexibility in timing. I planned my day around those priorities. I first spent focused time on the production issue. I checked curl locks, correlation IDs, affected transaction count, error pattern, recent deployments, workaround availability. Once I confirmed the issue was limited and not growing, I shared an update with support and my lead. Then I reviewed my teammates' pull request because they were blocked. I focused on check. Correctness? Check. Regression risk? Check. Test coverage? Check. API contract? Check. Security concerns. After that, I returned to my own feature work. I also communicated my updated progress during stand-up, so expectations were clear. Result: the production issue was monitored and moved forward. My teammate was unblocked. My API work continued with minimal delay because I prioritized based on impact and dependency. Why this answer works? This answer is strong because it shows context switching, impact-based prioritization, team collaboration, production awareness, code review responsibility, transparent communication. Example 6. Urgent bug fix and planned demo situation. In one sprint, we had a planned demo for a new feature. On the same day, QA found a serious bug in a related API that could affect the demo flow. The team had limited time to prepare both the fix and the demo. Task: I needed to help fix the bug while still making sure the demo could happen successfully. Action: I first worked with QA to understand the severity of the bug. I checked. Check whether the demo flow was blocked, whether production users were affected. Check whether there was a workaround. Check what endpoint failed, what data caused the issue. Check what regression risk existed. I found that the bug affected one edge case, but could appear during the demo if a specific data condition existed. I discussed options with the product owner. The options were: CAC, fix the bug before the demo. Adjust demo data to avoid the edge case. Postpone the demo. Demo only the completed safe flow. I recommended fixing the bug because the change was small and directly related to the demo path. I made the fix, added a regression test, and asked QA to validate the specific scenario. At the same time, I helped prepare safer demo data and shared the known limitation clearly. Result: the bug was fixed before the demo. QA validated the scenario. The demo went smoothly, and the team avoided showing an unstable flow. Why this answer works? This answer is good because it shows prioritization under time pressure, QA collaboration, demo readiness, risk assessment, clear stakeholder communication, practical execution. Example 7. Security review and feature delivery situation. In one release, I was completing a backend feature that involved user role permissions. At the same time, the security team requested changes to logging because some logs included too much request detail. Both were important because the feature needed to be delivered, but security risk could not be ignored. Task: I needed to handle both priorities without delaying the release or compromising security. Action. I first reviewed the security concern. I confirmed that some log statements included fields that were not necessary for troubleshooting. I prioritized removing risky logging because security and data protection were non-negotiable. I updated the logs to remove full request payloads, tokens, authentication headers, personal data, sensitive account details. Then I kept safe troubleshooting information. Correlation ID, correlation endpoint name, correlation status code, correlation error category, correlation step, correlation timestamp. After that, I returned to the role permission feature. I updated the implementation and tests for admin user access, normal user blocked, missing token, invalid token, audit logging, forbidden response. I communicated to the product owner that I handled the security item first because it had compliance and production risk. Result: the security issue was resolved. The feature was still delivered for the release. The team improved its logging standards for future work. Why this answer works? This answer is strong because it shows security prioritization, delivery balance, risk-based decision-making, safe logging, role-based access testing, stakeholder communication. Example 8. Multiple bugs before release situation. Before one release, QA found several issues at the same time. Some were minor UI or message issues, but one backend issue affected role-based access. There was limited time before the release candidate needed to be finalized. Task. I needed to help prioritize which issues needed to be fixed before release and which could be deferred. Action. I reviewed the defect list with QA and the product owner. We classified each issue by user impact, security risk, production risk, frequency, workaround availability, business priority, regression risk, testing effort. The role-based access issue was the highest priority because it could allow incorrect access behavior. The minor message issues were lower risk. I recommended that we fix the access issue before release and defer the cosmetic issues to a follow-up patch. For the access issue, I updated check authorization check, check service layer permission validation, check forbidden response, check audit log, check unit tests, check QA validation notes. I also helped document the deferred items so they were not forgotten. Result: the release went out with the critical access issue fixed. Lower risk issues were tracked for follow-up. The team made a clear risk-based decision instead of trying to fix everything under pressure. Why this answer works? This answer is good because it shows defect prioritization, security awareness, release judgment, QA and product owner collaboration, risk-based decision-making, responsible deferral. Best short answer version. If you need a short interview answer, you can say, in one sprint, I was working on a new Spring Boot API feature when support reported a production issue affecting some users during profile updates. Both items were important. The feature had a committed sprint timeline, but the production issue had immediate user impact. I assessed the priorities based on severity, user impact, workaround availability, QA timeline, and business impact. I decided to pause the feature temporarily and investigate the production issue first. I communicated this clearly to my team lead and product owner, so expectations were aligned. I reviewed logs, request payloads, correlation IDs, and recent changes. I reproduced the issue and found that one optional field was not handled properly. I made a focused fix, added regression tests, supported QA validation, and monitored after deployment. After that, I returned to the sprint feature and focused on the critical acceptance criteria first. As a result, the production issue was resolved quickly, and the sprint feature was still delivered because I communicated early and adjusted the remaining work carefully. Common mistakes to avoid. 1. Saying everything was equally important. Bad answer. I treated everything as high priority. Better answer. I compared urgency, user impact, business value, dependency, and risk before deciding the order. 2. Not communicating priority changes. Bad answer. I stopped working on one task and moved to another. Better answer. I informed the product owner and team lead about the priority shift and explained the impact. 3. Ignoring other people's blockers. Bad answer. I focused only on my own task. Better answer. I handled quick blockers for QA or front-end first when it helped the whole team move faster. 4. Trying to finish everything at once. Bad answer. I worked on all tasks at the same time. Better answer. I organized the work by urgency and dependency, then handled one priority at a time. 5. Sacrificing quality to move faster. Bad answer. I skipped testing because there were too many priorities. Better answer. I used risk-based testing and kept the most critical validation in place. Best practices for answering this question. Plus, use the STAR method. Plus, explain what priorities were competing. Show how you assessed urgency and impact. Communicate trade-offs clearly. Handle blockers strategically. Protect quality and security. Avoid multitasking everything at once. Align with stakeholders. Deliver the highest value work first. Positive result. What interviewers are looking for. Interviewers want to see whether you can. Click prioritize under pressure. Manage multiple responsibilities. Understand business impact. Communicate trade-offs. Support team blockers. Avoid panic. Protect quality. Deliver important outcomes. For senior roles, they also want to see stakeholder management, risk-based decision-making, production maturity, release judgment, ability to balance delivery and quality, leadership during ambiguity, ownership of priorities. Strong words to use in your answer. You can use words like check prioritized, check assessed impact, evaluated urgency, check clarified expectations, check communicated trade-offs, check unblocked, check coordinated, check adjusted scope, check protected quality, check reduced risk, check aligned stakeholders, check delivered value. Example. I dealt with competing priorities by assessing user impact, urgency, dependency, and business value, then communicating the trade-offs clearly, and focusing first on the work that reduced the highest risk or unblocked the most people. Good competing priority topics you can use. Depending on your experience, you can talk about check sprint feature and production issue, check multiple stakeholder requests, check feature deadline and technical debt, check product scope change and sprint commitment, production support and code review, check urgent bug fix and planned demo, check security review and feature delivery, multiple bugs before release, check QA blocker end, development work, deployment support and feature work, front-end integration and back-end implementation, documentation and coding tasks, performance issue and new feature, urgent support ticket and planned story, release preparation and defect fixes. Final summary. Tell me about a time you dealt with competing priorities. Is an important interview question because software developers often need to balance feature work, production issues, QA support, code reviews, stakeholder requests, security concerns, and deadlines. The best answer should include what priorities were competing, why each priority mattered, how you assessed urgency and impact, what you handled first, how you communicated trade-offs, how you adjusted your plan, what result improved, what you learned. Good examples include check sprint feature versus production issue, check multiple stakeholder requests, check feature delivery versus technical debt, scope change versus sprint commitment, production support versus code review, check bug fix versus demo, check security review versus feature delivery, multiple release bugs. The strongest answers show prioritization, communication, business awareness, risk management, quality ownership, and calm execution.